Out beyond the familiar orbits of the planets, where the sun's light fades to a dim glow, lies a region of space so distant, so cold, and so shrouded in mystery that it has long been considered an uncharted frontier of our solar system. This is the Kuiper Belt, a vast expanse that stretches beyond the orbit of Neptune. It is a realm of ancient frozen objects, a domain where time seems to have stood still since the birth of our solar system. The Kuiper Belt is a place not often seen by human eyes, and yet it is one of the most important and unexplored regions of our cosmic home. The cold emptiness of the Kuiper Belt contrasts sharply with the familiar warmth of the sun, yet in its icy silence, it holds clues to the origins of the solar system itself. Hidden within this frozen expanse are remnants of the early days of our cosmic neighborhood, objects that were once the building blocks of the planets and moons before being cast out into the farthest reaches of space. The study of these ancient relics offers an unparalleled opportunity to unlock the secrets of our solar system's formation. And perhaps, in doing so, we will answer some of the most profound questions ever asked. How did our solar system come to be? Could life have originated elsewhere in the solar system? And what mysteries does the Kuiper Belt itself hold? The Kuiper Belt stretches across a vast distance, about 30 to 50 astronomical units, AU, from the Sun. To put that into perspective, 1 astronomical unit, or AU, is the distance between Earth and the Sun, roughly 93 million miles. So the Kuiper Belt lies 3 times farther from the Sun than Earth, extending outward like a massive ring around the solar system's outer reaches. Far from the light and warmth of our Sun, the region is frozen in a deep, cold silence. Temperatures here dip to hundreds of degrees below freezing. The objects within the Kuiper Belt are composed largely of volatile ices, water, methane, and ammonia, frozen solid under the cold, unyielding conditions. Yet, despite the inhospitable environment, the Kuiper Belt is a place where the raw material of the solar system was once gathered. These objects are like time capsules, frozen in place since the very formation of the solar system over 4.5 billion years ago. They are remnants of the building blocks that once came together to form the planets, moons, and other objects that we know today. Unlike the planets, which have been shaped and reshaped by forces like gravity and internal heat, the objects in the Kuiper Belt have remained relatively unchanged, preserving a snapshot of the early solar system in their frozen cores. At the heart of the Kuiper Belt lies one of the most famous objects in our solar system, Pluto. Pluto is not only a dwarf planet, but a symbol of the mystery and complexity of this distant region. For decades, Pluto was considered the 9th planet, only to have its status changed in 2006 when the International Astronomical Union redefined what constitutes a planet. Despite this reclassification, Pluto's importance has only grown. This icy world, with its quirky orbit and rich history, has become a symbol of the Kuiper Belt itself. In 2015, NASA's New Horizons spacecraft made history by becoming the first probe to fly past Pluto. The images it sent back were nothing short of astonishing. Far from being a cold, lifeless rock, Pluto revealed itself to be a dynamic world. Vast plains of frozen nitrogen, towering ice mountains, and vast, frozen basins like the heart-shaped Sputnik planitia. All these features pointed to an active geological past. The fact that Pluto's surface is still evolving, even at such a great distance from the Sun, challenges our previous understanding of icy worlds on the outskirts of the solar system. What we once thought was a static, unchanging world has turned out to be far more complex and intriguing. But Pluto is just one of many intriguing inhabitants of the Kuiper belt. There are countless other objects, each with its own unique features. Take Haumea, for example, one of the most unusual objects in the entire solar system. Haumea's elongated shape is the result of its rapid rotation, which causes it to stretch out into a shape more akin to a rugby ball than a sphere. This rapid spin is not only an intriguing feature, but Haumea is also one of the only known objects in the solar system with a ring system. These fascinating characteristics make Haumea one of the most mysterious and scientifically valuable objects in the Kuiper belt. Then there's Eris, a distant dwarf planet that's almost as large as Pluto, yet far more isolated. Eris lies at the very outer edge of the Kuiper belt and has an orbit that is tilted at an angle to the rest of the solar system's planetary orbits. Its surface is covered in a layer of frozen methane, and it's believed to be one of the coldest objects in the solar system, with temperatures reaching near absolute zero. Despite its isolation, Eris also has a moon, Dysnomia, which offers further clues about its formation and history. Eris is a testament to the diversity and complexity of the Kuiper belt, a region teeming with objects that are far more than just frozen rocks. The Kuiper belt is also home to the comets, icy wanderers that are some of the most spectacular and enigmatic objects in the solar system. These comets, which come from the farthest reaches of the Kuiper belt, are thought to be some of the oldest objects in our solar system. They are remnants from the very beginning, containing material that dates back to the solar system's formation over 4.5 billion years ago. These comets are often seen as time capsules, preserving clues about the chemical makeup and conditions of the early solar nebula, the cloud of gas and dust from which the sun and planets formed. When comets venture close to the sun, the heat causes their volatile ices to vaporize, creating the spectacular tails we see from Earth. This process, called outgassing, is what makes comets so beautiful, but it also provides us with valuable scientific data. The chemical composition of comet tails can tell us a great deal about the early solar system and the kinds of materials that were present in its formation. In fact, some scientists believe that comets may have played a critical role in delivering water and organic compounds to Earth, perhaps even helping to seed the conditions necessary for life to emerge. But the Kuiper belt is not just a collection of strange and fascinating objects. It holds a key to understanding the very formation of the solar system itself. These objects were born out of the same raw materials that came together to form the planets and moons. But while most of the material from the early solar system was swept up into the larger planets, the objects in the Kuiper belt were left behind, preserved in their frozen, unchanged state. As a result, studying the Kuiper belt is like peering back in time, to the very beginnings of the solar system. The Kuiper belt is also a place of mystery. There are hints that this region could contain far more than we've yet discovered. Some scientists believe that the gravitational effects of unseen objects in the Kuiper belt, or beyond it, could explain some of the unusual orbits of distant objects like those in the Oort cloud. Could there be a ninth planet, an as yet undiscovered world, lurking on the fringes of the solar system? The idea of a hidden, massive planet at the edge of the solar system is one of the most tantalizing possibilities in modern astronomy. What other secrets might the Kuiper belt be hiding? The exploration of the Kuiper belt is just beginning. The New Horizons spacecraft, which captured humanity's first close-up images of Pluto, is continuing its journey deeper into the belt, exploring objects like 2014 Mu-69, now known as Arrokoth. This primitive, peanut-shaped object, located even farther from the Sun than Pluto, offers a glimpse into the formation of the solar system. Its unusual shape and composition provide critical data about the early stages of planet formation.